Okay, let's do this normal distribution problem. This is number 46 from chapter 5 from your textbook. Pause and read the question. Okay, hope you've done that. Remember our 3 steps here are draw the picture, find our z-scores, normal CDF. So remember, with the normal model, I can never find the probability of hitting one number exactly. I always have to shade something. They just say hit 40,000. I have to shade something. If we are not told what to shade, always shade a tail. So I'm going to shade above 40,000, this little tiny tail here. Then we'll find the probability of being there or above. Okay, we find our z-scores, the one we want, the one in the question, minus the one in the middle of our picture, divided by the standard deviation. We get 3.2. That is a big z-score. A car that gets 40,000 miles, or a tire that gets 40,000 miles, is 3.2 standard deviations above the mean. And then we do normal CDF. Smallest thing we shaded to largest. The smallest thing we shaded was his z-score, 3.2, and then I shaded all the way to infinity. Remember, up at this end is 99 or infinity, and down here is negative infinity or negative 99. So normal CDF, 3.2 to 99. So we type that in the calculator. 3.2, comma 99. Remember, always leave these alone. Don't change that. Leave that 0 and 1 or you're going to have a bad time. And we get this number. Now you got to be careful with this. That is scientific notation right there. This is 6.87 times 10 to the negative fourth. You will never, ever, ever have a probability bigger than 1. You can't have 687%. If this number is bigger than 1, you have to look over here and be careful. This is a very, very small number. That's 6.87 times 10 to the negative fourth power. So if we move the decimal point over 4 places to the left, we get about 0.0007. So the probability that the tires last 40,000 miles or more is that very tiny number. That is not reasonable. So I would not expect my tires to last that long. Okay, now we want to know what fraction or what percent of the tires last less than 30,000 miles. So same steps, draw the picture, find the z-scores, normal CDF. Here's our picture. Notice I shaded below 30,000 because it says less than. Notice I've shaded a little tiny amount. I shaded way less than half. If I get an answer like 70%, I know I've goofed. There's no way I've shaded 70% of this picture. Find my z-score, the one I want, minus the one in the middle, divided by the standard deviation. I get a negative z-score. Negative z-scores are below the mean, positives are above the mean. Now I got to normal CDF that. How far down did I shade? What's the lowest thing I shaded? Negative infinity, or negative 99, up to negative 0.8. Now you got to be careful typing negatives into your calculator. See, watch, if I type minus 99, if I type this, minus 99, no matter what the other one is, it's going to give me an error. Because this is the minus sign, this is the negative sign. So I want second vars, number 2, always number 2, negative 99 to negative 0.8. And I get about 21%. So the probability that the tires last 30,000 miles or less is about 21%. Or another way to say that is about 21% of tires last less than 30,000 miles. Okay, now let's go between two values, between 30,000 and 35,000 miles. Draw the picture, it's a required step. Find both z-scores, the one you want minus the one in the middle over the standard deviation. Notice his z-score was negative, his was positive. He's below the mean, he's above. Normal CDF, smaller, larger. We get about 67% of tires last between those two values. Don't forget the units. Don't forget to write miles. And then, finally, pause the video and read this question. I hope you've done that. So the dealer doesn't want to give a lot of refunds. He only wants to give it to 1 out of 25. That's the bottom 4%. So we only want the tires that are terrible, the bottom 4%, to get refunds. So we want 96% to not get the refund. We're looking for the 4th percentile. So remember, for percentiles, we use inverse norm. So I'm going to go into my calculator, second distribution, number 3, inverse norm. We always want to type in our area below the value we're looking for. So 0.04. Leave the 0.1, leave that on left. Hit enter. We get a z-score of negative 1.75. Remember, inverse norm spits out a z-score. I'm looking for the tire that is 1.75 standard deviations below, because that's negative, the mean. So we use this formula, x equals z sigma plus mu. If you don't know what all the symbols stand for, you're going to have a really bad time here. We get this number, 25,625. So that's the 4th percentile. 96% of tires last more than that. So only customers that get less than that will get the refund. And that's the bottom 4%.